In previous lectures, we discussed about the introduction of big data analytics, and that lecture was informative. We can understand this big data analytic course at three levels. One can be information level, so lecture can be informatic. Second, this course we can understand at practical level, and nowadays people use one word that is called skill set. Third level, theoretical level, that is what is theory behind it. Or underlying theory. So now the remaining portion we will cover, or we will try to cover at all these three different levels. Okay. So next is the Hadoop. And the programming model that is to be used here, that is MapReduce. So whether this Hadoop or this big data analytics can be applied for all kinds of problems? Is there any such limitation or not? Second, what is this Hadoop? And as we discussed in previous class, when we have big data problem, the natural solutions, if we try to find out, so two ideas are dominating. One is the parallelism, and other is the distributor or distribution. Parallelism and distribution. So when we divide one part, big part, into several smaller parts, so certainly now system is distributed. Now the parallelism comes picture only if we talk about some kind of processing is taking place here and there. So we have big data. So big data have to be divided into parts, and it is to be executed in parallel on several different machines. Very simple to understand, and this will be applicable throughout the whole course. Now question is, when we say distribution of data, so data is distributed or computation is also distributed? And if we say if data is distributed on several different locations, then what about the computation? So here computation is distributed or computation is copied on other machines. Same computation is being carried out on other machines. So computation problem cannot be handled straightforward manner. Not all kinds of computation can be carried out in parallel. Sequential operations, and there is any kind of dependency among the operations or among the computation. So that kind of dependency have to be taken care. So question arises here, what kind of computation we should permit on this MapReduce or Hadoop. So this MapReduce, one way of programming, it suggests that we have data and we divide data into parts and we allocate. Map means allocation. We allocate data to different machines. And on those machines, the computation is carried out. So question is that same kind of computation must be carried out on data at one time. So all these have to be discussed here. Whether all kind of operations are allowed. After computation, the result have to be sent somewhere. So partially the result are sent or the result are reshuffled or data is to be reshuffled at the beginning. So reduction process says that we have more input and less output. So some kind of data values you can say have been, number of data values have been reduced. So mapping and reduction, two operations becomes important here. So how the problem should be visualized in the terms of mapping and its map and reduce model. What should be the nature of the computation? Okay, so all have to be discussed. So that come under the MapReduce. What is the mathematics behind it? And so today, first of all, we will discuss this Hadoop. So we will first go to Wikipedia for Apache Hadoop and to have general information and high quality of information. I have seen that on Wikipedia you have Wikipedia is good source. Then we have one Hadoop website and there is one web page link where Hadoop has been installed on Windows 10 and this is one vlog of a person. Last year I discussed vlog of this person in Hadoop installation, but by the way that vlog has been removed and other source can be tutorial point and Java point. Tutorial point and Java T point. They are website where you can get some practical information related to this and they are also useful to learn. So we will also try to explore some useful literature material there. Okay. So now I go to this Wikipedia. I read one sentence, then I will explain. Then we will go some other sentence. So in this way I will speak. Apache Hadoop is a collection of open source software utilities that facilitate using a network of many computers to solve problems involving massive amount of data and computation. So there is nothing to explain. It provides software framework for distributed storage and processing of big data using MapReduce programming model. So MapReduce is a programming model, one way of writing program. Hadoop was originally designed for computer clusters built from commodity hardware, which is still the common use. It has since also found use of use on clusters of high-end hardware. So when we say Hadoop framework, so as I told framework, we can understand. So here you can assume framework. Here Hadoop is a collection of programs or collection of software. And using all those software, we carry out the activity of large data computation. And the model programming skill or programming technique we use, that is called method. All the modules in Hadoop are designed with a fundamental assumption that hardware failure are common occurrence and should be automatically handled by the framework. Now, when we have machines on internet or machine on network, not internet, machine on network, uh, then data transfer and application of program or code transfer takes place. And because of practical problems, there are chances of failures. So when we want to provide a framework, then we have to take care all those issues of failure so that smooth computation could be carried out. So this Hadoop takes care all those practical problems. So I shall tell you, by default, our data file is kept at 3 different locations. That means, suppose one data file, because of any reason, damaged, then it is possible to recover the same data from some other source. So I tell you, there are several racks, and in each rack there are several machines. So if somebody says I have to keep 3 copies of the same data, so where I should keep? One can suggest that all 3 copies of the data may be kept on 3 nodes or 3 machines of one rack. Now here, if somebody says if rack entire rack goes on down, then all the data will lost. So the better solution can be you keep all 3 copies on 3 different racks. So at a time, one rack go down, then data can still be recovered. So all these kind of precautions are suggested, and the computation also takes place in the same way. The core Apache Hadoop consists of storage parts called Hadoop distributed file system. File system, you understand, in operating system, file system is a one how data is stored and it is managed. So when we say file system, that means It provides the facility how to name a file, how to copy file, how to delete file, all these operations which are part of the file system. So similarly here, when we have distributed computation, what should be the nature of file system? So that file system we call Hadoop distributed file system. Basically, this kind of file system, first time this Google proposed, Google developed and implemented. So that was called Big Google Big File System. Exactly, I will tell you later when we have some other discussion. So then the literature, the paper article came, and Google also shared this information in public domain. Then immediately this open source solutions people started, and first solution came this Hadoop, and later on improvement version also came, and today we have Hadoop 3 point something. So earlier Hadoop-1, then other version, etc. So the core of Apache Hadoop consists of storage part known as Hadoop distributed file system and processing part which is MapReduce programming model. Hadoop splits files into large blocks and distributes them across nodes in a cluster. Cluster is collection of computer or machine or nodes. It then transfers packaged code into nodes to process the data in parallel. So this is written here, packaged code. Basically, it is a what computation is to be performed. So code is also transferred, data is also transferred. This approach takes advantage of data locality. Data locality means suppose I have I have to perform some computation, and suppose I write a program that does some computation. So my program will be in the RAM. So first of all, the program will be transferred to RAM, then data has to be transferred to the RAM. So first I will load my program, then I will transfer from secondary storage to main memory. Then each instruction one by one carried out of the program, and instruction is operated on the data, and some result is calculated or any intermediate result, whatever. Now here the data is available locally on my machine. Now if I extend this model, I can make client server model. I am on my client side and the server is some on different distant machine, and I do some computation. So what are the possibilities? I can send that so and so computation I require, so I can send data from my client side and computation may take place at the server side. It has still two more possibilities. One, either whole computation may be carried out at the server side, or some computation that I require more frequently, I should carry out on my local client machine. Okay, so I can divide such whole computation into two parts depending on my own requirement. So the computation carrying out at my client side, I can say locally data is available. Okay, so if data is available locally, and it is convenient to me, and if I every time get data from distant machine, and it is a time consuming process, chances of failure, okay, communication time will also be there. So all these problems will be there. So locality of data property should be exploited. Okay. So here it is written, it then transfers packet data into nodes to process data in parallel. This approach takes advantage of data locality. So it is simply data is locally available. Where nodes manipulate data, they have access to. This allows the data set to be processed faster and more efficiently than it would be in a more conventional supercomputer architecture that relies on parallel file system where computation and data are distributed via high-speed networking. This is another model that I have not discussed. But in supercomputer, the issue of parallelism is exploited, and there we have very large number of large number of CPUs on one machine. Okay, and there is one more layer of the operating system that manages all those no processors, multiprocessor, you can say multiprocessor system. So a base Apache Hadoop framework is composed of the following modules, following parts. Okay, so this is base means or minimal. इतना तो होना चाहिए, minimal modules which are supported by the this Hadoop. One is the Hadoop common, contains libraries and utilities needed by other Hadoop modules. Okay. Hadoop distributed file system are distributed file system that stores data on commodity machines, providing very high aggregate bandwidth across the cluster. Now, when we say distributed file system, that means the system should be able to name all the nodes on the network. The system should be able to, the file system should be able to uh, perform operations on distributed file means or file on other locations also. So how it can be, we will see when we have discussion on Hadoop distributed file system. A distributed file system that stores data on commodity machines providing very high aggregate bandwidth across the cluster. Hadoop yarn, it is a scheduler. So it was introduced in 2012, a platform responsible for managing computing resources in cluster and using them for scheduling users' applications. Hadoop MapReduce, an implementation of the MapReduce programming model for large-scale data processing, and Hadoop Ozone, an object store for Hadoop. I am also reading it first time. It is introduced in 2020. Okay. That's why I told this is good source of Wikipedia. The term Hadoop is often used for both base modules and submodules and also the ecosystem or collection of additional software packages that can be installed on top of the alongside Hadoop. Such Apache. Now here I tell you one word ecosystem. Ecosystem as the literal meaning ecological balances. It makes some kind, nature has some inbuilt feature. It make balances. So similarly, when we have to perform big data computation, what component I should use so that they could interact with each other or they could coordinate and cooperate such that as a whole system will function comfortably or conveniently. So this when we say Google, this Hadoop ecosystem, that means we are talking about all the components of Hadoop system. They are selected such that they coordinate, they cooperate to compute the this big data problem, to solve the big data problem efficiently or conveniently. So this is nothing ecosystem, any kind of other meaning. So in addition to these five these system, what are other components? So the term Hadoop is often used for both base modules and submodules, and also ecosystem or collection of additional software packages that can be installed on top or alongside of the Hadoop. Several such software packages are there. So such as Apache Pig, Apache Hive, Apache HBase, Apache Phoenix, Apache Spark, Apache Zookeeper, okay, Cloudera, and Apache Flume, Apache Scoop, Apache OZ, Apache Storm, and many more maybe. Some commercial software may also have some kind of compatibility. So Apache Hadoop MapReduce and HDFS components were inspired by Google paper. This is the paper that I was talking. Google paper, and on MapReduce and Google file system. This is Google file system. Okay. Google File System is a proprietary distributed file system developed by Google to provide efficient, reliable access to data using large clusters of commodity hardware. The last version of Google File System, condemned clauses, was ignored. Okay. So now we come, which one is more relevant to us, then we will go directly to that. So history, I have discussed architecture. So this is written here, architecture here. Basically, we can say whole system can be divided into two parts: storage part and computation part. So here LDFS layer and it is MapReduce layer. So here it is data node, name node. Name node is a master server, master or server like server. This node, basically this node has all the names, or this has all the information of all other nodes. So it is known as name node. This is file system. So I first go to the architecture. Hadoop consists of Hadoop common package, which provides the file system and operating system level abstraction. Hadoop common. So it includes file system and operating system level abstraction. A MapReduce engine, okay. MapReduce and Yarn. Yarn is a scheduler program. Scheduler means that takes care of this chunk of data. This part of data may be allocated to this machine or that machine. Now it should start like on this time, that time. So all that kind of scheduling. Hadoop file system, HDFS, and Hadoop common package contains Java. And this Java archive. The effective scheduling of work. Every Hadoop compatible file system should provide Hadoop or Hadoop compatible file system. Okay. There is HBase is also one file system. It is compatible. That will come. Location aware. This is Hadoop compatible file system should provide location awareness, which is name of the rack, name of the rack, especially the network switch where the worker node is. In one rack, we have several worker node or machine. Hadoop applications can use this information to execute code on the node where data is, and failing that, the same rack switch to reduce backbone traffic. Hadoop application can use this information to execute code on the node where data is, and failing that, if that data is not available because of some reason, on the same batch, switch to reduce backbone traffic. LDFS uses this method when replicating data for data redundancy across multiple racks. This approach reduces the impact of a rack power outage or switch failure. If any of these hardware failure occurs, the data will remain available. Okay. A small Hadoop cluster includes single master and multiple worker nodes. The master node consists of job tracker and task tracker, name node, data node. A slave worker node acts as both data node and task tracker, though it is possible to have data only and compute only worker nodes. These are normally used only in non-standard applications. Hadoop requires Java runtime environment and or higher the standard startup or shutdown script that secure shall be set up between nodes in the cluster. In larger cluster, LDFS nodes are managed through dedicated name node server. Okay. File system, this is written here, what services the file system provides. Hadoop distributed file system is a distributed, scalable, portable file system written in Java for Hadoop framework. Okay. If I say file system is a program written in Java for so and so purpose, it will be easy to understand. So it is a distributed, scalable, we can expand, portable file system written in Java for Hadoop framework. Some consider it to instead of data store due to its lack of POSIX compliance. Yes, but it does provide shell commands and Java application programming interface methods that are similar to other file systems. A Hadoop instance is divided into LDFS and MapReduce. LDFS is used for storing data and MapReduce is used for processing this. LDFS has 5 services. Here. Name node, secondary name node, job tracker, data node, task tracker. Other file system. Hadoop works directly with any distributed file system that can be mounted by the underlying operating system by simply. However, this comes at a price, the loss of locality. To reduce network traffic, Hadoop needs to know which server are closest to the data information that Hadoop specific file system bases can provide. In 2011, the list of supported file system bundles with Apache Hadoop were ADFS, they are the name of the file system. ADFS, then Apache Hadoop Ozone. ADFS compatible object stores targeting optimized for billions of small file. FTP, you might be knowing this FTP. Amazon S3, object storage. This is the targeted that clusters hosted Amazon Elastic Compute. Window Azure Storage. It will be easy to learn Hadoop if we have some practical understanding. Okay, so all of you go to install Hadoop on your system. So I will tell you there are two slides here: how to install Hadoop, how to use Hadoop. Okay, and last year I delivered one lecture on this how to install. So I will share that video also because that below is not available here. So I tell you this is how to install Hadoop. In addition to that, YouTube video you can see. So on different machines, you can different operating system. You can install Hadoop on Windows, Ubuntu, Linux, and one more Mac machine. So you can see these slides also. We will learn how to add users. Installation of Hadoop is not straightforward. We can install Hadoop in three different modes. One mode is the single standalone machine. Second is fully distributed. Second is pseudo cluster on the same machine. Then third is fully distributed. That means full-fledged production level installation. Okay. So all of you try to install on a single standalone machine. So here, this here you will find in installation one is also written get started here. Hadoop setting up single node cluster. Some information you will get from here. And this is one more link in installation on 3.21, but you don't go this latest version. You try to install Hadoop somewhat older because it is more stable. The new versions have chances of more chances of error. Okay, so it is better to install lower version of this Hadoop, not this higher version. Avoid this. Last year it was observed. So you take example of installation that is given in the video, and third, this is one below. If you want to go through that, you can just go and read it. Okay? But no new information is there. So these slides you can go, they are easy. How to add user, how to install and configure. The installation requirement. This is screenshot also. Java installation. Okay. So these slides will help you. And one more slide is there. This is PPT slide. How to use. Okay. You have to format name node, start stop Hadoop ecosystem with command line. So I advise all the student, you go. It is also one experiment in your lab class. Install Hadoop, then we will discuss some programs. Thank you.